Right, some calculations involving standard form then. So we're going to look at how we can put numbers with standard form into our calculator to carry out some basic calculations. Okay, so looking at the first one then, we want to do 3 times 10 to the power of 2 times 2 times 10 to the power of 3. Now you can do this without a calculator. Your numbers at the start just get multiplied as normal, and then you use your rules of indices to do your powers. Okay, but you don't need to worry so much about that for this course, so we will just think about using our calculator. Okay, this times 10 to the power of has a special button on your calculator, so you're not going to hit the multiplication button and you're not going to type in 10. You're going to use the button on your calculator. I'll show you on this calculator here. If you've got your own calculator there, make sure you're typing it in at the same time so that you know that you're pressing the right buttons. If you can't find these buttons on your calculator, please get in touch and we'll get it sorted out. Okay, so 3 times 10 to the power of 2. If I was to write that out in full, that would be 300. If I was to write 2 times 10 to the power of 3, it would be 2000. Multiplying together would be 6, 0, 0, 0, 0, 0, which is 6 times 10 to the power of 1, 2, 3, 4, 5. On our calculator then, we're going to do 3 times 10 to the power of, and that does that whole bit for you. All you need to do then is put in your power. If I press equals here, you'll get your 300. So your calculator will also write your numbers out in full or for you from scientific notation as long as they're not too big. I'm going to multiply that by 2 times 10 to the power of 3. So again, typing that in, I've done my 2. The times 10 to the power of is all in that one button. I'm just putting my extra number in there. Hit equals, and it gives me my 60,000. Because my calculation started in scientific notation, what will quite often happen is you'll be asked for your answer in scientific notation as well. You can write it down and then get your answer into scientific notation. The next one, 4 times 10 to the power of 6 times 5.1 times 10 to the power of 2. Again, just a case of typing it into a calculator. 4 times, sorry, wrong button, distracted there by my dog. 4 times 10 to the power of 6 times 5.1 times 10 to the power of 2 equals, and I get, and this is why I hate this because as soon as I start writing this disappears, 1, 2, 3, 4, 5, 6, 7. I get 204 with 7 zeros after it. 1, 2, 3, 4, 5, 6, 7. I want this back into standard form, so I get 2.04. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the power of 9. Next one, we've got 6.3 times 10 to the power of 2 times 5.1 times 10 to the power of 3. The brackets here don't mean anything. The brackets are just to separate out the numbers that are in standard form from the operation that we're trying to do, which here is multiplication. Okay, so my first number, 6.3 times 10 to the power of 2 times 5.1 times 10 to the power of 3. And we get 3213 and 3 zeros. 321312. 3 zeros back into standard form then. I need to move my decimal point to here. So I get 3.213. Try not to leave a mark like that on it because then it becomes incorrect. 1, 2, 3, 4, 5, 6. Sorry if this is picking up. My dog is playing with a toy that makes the sounds of a cat. Sorry if it's picking up there. So we get 3.213 times 10 to the power of 6. Next one then, difference with this one is we're starting to include some negative powers, some smaller numbers. So let's make sure we're confident with putting that into our calculator as well. The first one, we get 8.6 times 10 to the power of 2, so that's the same as before. The next number, we're putting this negative in, So it's 1.7, so times 1.7 times 10 to the power of, no difference there. Now when I want to put in my -5, I'm not using the takeaway button. I'm not using this one here. I'm using my negative button, which for my calculator is up here in a bracket. Some of them have a plus stroke minus button. This seems to be the most common one now. It equals, and it's given me 731 over 5,000. I don't want that. Oh, sorry, 50,000. The button, I get 0.01462. 0.01462 in standard form then. I get 1.462 times 10 to the power of 2, -2. Try not to leave these dots behind in case they look like extra decimal places. Okay. Both negatives this time. Like I said before, it's worth getting your calculator out, typing this in, checking you get the same answer as me. Any problems, let me know. So we get 3.1 times 10 to the power of -2 times 1.6 times 10 to the power of -3. And that gives me 4.96 times 10 to the power of -5. So this time the calculator has given it to me in standard form or scientific notation. Make sure you're noticing this wee bit down here that's saying times 10. You need the full part in for it to be in standard form. So 4.96 times 10 to the power of -5. We don't just multiply, we can divide, we can add, we can subtract, we can do anything like the scientific notation. They are just numbers, just written in a different way. Let's try dividing one. We're going to do 3.4 times 10 to the power of 6 divided by 1.9, point didn't come out, 1.9 times 10 to the power of 2, and that comes out as 17894.73684. Now we get to use our rounding and as well as our scientific notation this time. So at this time I'm going to ask for an answer to 2 decimal places. So 2 decimal places, I'm looking for my third number after the point, which is a 6. That 6 is going to round that 3 up to a 4. That's to 2 decimal places. If we've got anything written as a fraction like this, a fraction just means divide. So we're doing 6.2 times 10 to the power of 4 divided by 3.5 times 10 to the power of 2, which is 177. Try again. 177.1428 was that? Yes. So again, 2 decimal places, 177.14. After the 4 is a 2, so it just stays as a 4. So that is to 2 decimal places. For the fraction one, again, fraction just means divide. So we're doing 6.4 times 10 to the power of 6 divided by 8.9 times 10 to the power of 3, which is 719. Seems I can't talk and write at the same time. 719.1011 and so on to 2 decimal places. Then we get 719.10. Okay. Can also get some wordy questions where we need to work out what calculation we're doing. So we have here a spider, which is 19.06 times 10 to the power of -5 kilograms. A hummingbird is 18 times heavier We want the weight of the hummingbird in scientific notation. So my spider is 19.06 times 10 to the power of minus 5. The bird is 18 times heavier, so I'm going to times that by 18. 19.06 times 10 to the power of negative 5 times 18 is 3.4308 times 10 to the power of negative 3. Next question then, we've got the formula E equals mc squared, quite a famous formula, hopefully somebody will recognise it. And we want to find the value of E if m is 3.6 times 10 to the negative 2 and c is 3 times 10 to the 8. So to work out E, I'm going to do whatever m is, which in this case is 3.6 times 10 to the power of negative 2. I'm just putting that in a bracket so it's clear what it is, that it's not part of the, trying to get my words right today. I've put that into a bracket so it's separated out from the operation. Sometimes with all the time signs with the times 10 to the power, it's just easier to see it that way. And I'm going to times that by 3 times 10 to the power of 8 squared. Now you can type this into your calculator all in one go. Otherwise you can square first if you prefer. Okay, so 3.6 times 10 to the power of negative 2 times 3 times 10 to the 8, and I'm just going to do 3 times 10 to the 8 again there because I forgot to put a bracket in. And when you square something, you times it by itself. So I get 3.24 times 10 to the power of 15. Last one then. The stress on a beam is found by dividing the applied load by the area of the cross section. Calculate this stress given that the load is 1.7 times 10 to the power of 4n and the cross-sectional area is 4.1 times 10 to the power of minus 3 metres. Give your answer in scientific notation. So we want to divide the load by the area of the cross-section, and that will give me the stress. So the load is 1.7 times 10 to the power of 4. So I want to divide that by 4.1 times 10 to the power of minus 3. Apologies again for background noise. I don't know what my puppy's up to. Right, 1.7, not 17, 1.7 times 10 to the power of 4 divided by 4.1 times 10 to the power of negative 3. And that is 414.6341. It'd be an awful lot easier if my calculator would stay there. 0.463. I'm asked for an answer in scientific notation. I'm not asked to round it any, so I need to keep all these numbers in. So I get 4.146341 times 10 to the power of, see how many spaces I've moved that decimal point. So I've moved it 1, 2, 3, 4, 5, 6 times 10 to the power of 6. I'll leave you to try some of these. As ever, any problems, please get in touch.